Have you ever seen a headline that says coffee is a superfood, and then like a week later, another one says it's terrible for you? It can feel like science just can't make up its mind. Well, today we're going to play detective. We're going to investigate how scientists find the real truth when it's buried under a pile of contradictory results. So here's our game plan. We'll start with why science seems so contradictory. Then we'll look at a super important tool called meta-analysis, and an even better three-step method for finding what's really going on. We'll even see it in action with a cool example, and wrap up with why this all matters so much.
Okay, so first things first. Let's really dig into the mystery we're trying to solve here. Why does it so often feel like research is just a big collection of, on the one hand, but on the other hand, statements?
And this is the big question, right? But here's the thing. Conflicting findings aren't actually a failure of science. It's just part of how science works. You got to think of every single study as just one piece of a giant, sprawling puzzle. The real trick is figuring out how all those different pieces actually fit together.
I mean, take open plan offices. You'll see one study that says, hey, they're amazing for creativity, and another one screaming, no, they absolutely kill productivity. So, who's right? Well, maybe they both are. The real question isn't which one is right, but why they got totally different results in the first place.
So how in the world do scientists take all these different clues and make sense of them? Well, they have a really powerful tool in their toolkit called a meta-analysis. Now, a meta-analysis isn't just, summarizing a bunch of papers. It's a full-on statistical method that combines the results from many, many studies. Think of it like this. If every study is one eyewitness to a crime, a meta-analysis is the master detective who interrogates all of them at once to piece together the most reliable story. And this is absolutely crucial. It's not about taking a simple average. No, it's a much smarter process that gives more weight to the bigger, higher quality studies. The whole goal is to find the true signal by tuning out all the noise coming from any single piece of research. But just finding the overall signal isn't quite enough. The real detective work, the fun part, is figuring out why that signal is stronger in some studies and weaker in others. We've got to find the hidden clues.
And this brings us to our key piece of evidence, something called a moderator variable. Basically, it's the it depends factor. So for our office example, maybe open offices work great for creative teams, but are a disaster for accounting teams. In that case, the type of work is the moderator. Finding these is how you solve the contradiction.
But of course, every good detective story has a villain. And in science, that villain is something called statistical artifacts. You can think of them as ghosts in the data, little errors and distortions caused by things like random chance or imperfect measurements. They're basically static that can completely hide the real story.
It's kind of like trying to listen to your favorite song, but it's buried under a layer of fuzzy static. For a long time, researchers could hear the melody, but it wasn't very clear. The big breakthrough we're talking about is a method that acts like a pair of noise-canceling headphones for data.
And that right there is the brilliant idea from our source paper. It's a method that meticulously filters out all that static so the real patterns, the music in the data, can finally be heard crystal clear.
Okay, don't worry, I promise there won't be a quiz on the math here. The main point is that the logic behind it is just beautiful. You have to systematically remove the noise first so that you can be confident that what's left is the real deal.
So here's how it works, in 3 pretty simple steps. First, you go into every single study and you clean out the noise. You correct for those statistical artifacts. Then, once everything is clean, you check if there are any real patterns left over. And if there are, well, that's when you go hunting for that hidden moderator that's causing them.
All right, theory's great and all, but let's see these noise-canceling headphones in action on a real-world question.
So here's the case they decided to test. Is the connection between how satisfied you are at your job and how committed you are to your company the same for men and women? Past research on this was all over the place, a perfect mystery for this method to solve.
This is the raw evidence file, data from 10 different studies. And just looking at it, the results are a total mess. All the numbers are different. It's a perfect pile of confusing clues for our data detectives to sort through. So, the researchers fired up their 3-step method. They cleaned out all that statistical noise from those 10 studies. And once the static was gone, the answer was totally clear. The link between job satisfaction and commitment is substantially stronger for women than it is for men.
And here is the statistical punchline. That little p less than 0.01 basically means there's less than a 1% chance that this result is just a random fluke. By cleaning the data first, they could prove this is a real pattern. Mystery solved.
So, okay, we solved one mystery about job commitment. Pretty cool. But the implications of a method like this are so much bigger. This is really why this method is a game changer. It lets us move beyond those simple yes or no questions like, does it work? And ask much smarter ones like, okay, for whom does this work and under what conditions? By separating the real signal from all the noise, it turns what looks like a messy contradiction into a much deeper, more reliable insight.
And as the authors themselves put it, this whole search for the it depends factors, well, it's at the very heart of the scientific enterprise. It's how we move beyond simple answers and start to get a true, nuanced understanding of our incredibly complex world. So the next time you see those conflicting headlines, just remember what's going on behind the scenes. Remember that science has these incredibly powerful tools for finding the melody inside the static. And it leaves us with this final, really fascinating question. Now that we're getting better and better at tuning out the noise, what other incredible truths are just out there, waiting to finally be heard?